This is section 1.1, identifying points, lines, and planes. First, let's define a few terms. First term is point. A point has no dimension. Okay, it's just kind of a spot, and it's represented by a dot, and then we usually label that dot, say that's point A, or you could write out point A. A line has one dimension, okay, it's represented by two arrows, but it extends without end, and that's what the arrows mean. So when you draw a line, you have to put arrows on the end to show that it continues forever in all directions, in both directions. There are several ways you can label a line. One way is if you just call the line a name, in this case L, you could say this is line L. Or you could use 2 points that are on that line. In this case we have line AB. If you use the word line, you can just put the letters. If you don't use the word line, then you can also label this as A, B, with the symbol of a line over the top of it. Also, you could flip those around and call this BA, line BA. As long as you use 2 points that are on that line, you can name that line, or you just name it from the beginning. Okay, the next figure we have is called a plane. A plane is two-dimensional. Has 2 dimensions. Okay. And a plane is usually drawn, if we use our template here, you can use the parallelogram template. So a plane looks similar to that, or shows that, even though you have to understand that the plane goes in all directions forever. So it's like a flat piece of paper that goes forever in all directions. If we put points on this plane, so there are several ways we can name a plane. One way is if we give it a specific name, like we did for a line, we could say that this is plane M, and just call it that. Or we could say it is plane A, B, C. You can use 3 points that are on the plane, and you have to use 3 points. Or another way is you'll see that they've made a little parallelogram to show it's a plane, and then A, B, C as well. Okay, so those are the 3 types of figures that we're going to talk about in this section today. A point, a line, and a plane. When points are collinear, okay, we know linear means line. So collinear points are points that are on the same line. So if I had a line here, and point A, point B, those 2 points are collinear because they're on the same line. Coplanar are points that are on the same plane. So if I had a plane with our points A, B, and C, then those would all be coplanar because they're all on the same plane. Alright, so if we have a plane, let me go ahead and use my template here. Draw a parallelogram. So that'll be my plane. And we're going to call this plane R. And through this plane we have a line that is actually in the plane there, and we're going to call this, we have 3 points here. We have point S, point P, and point T, and this line is within the plane. It's setting, it's inside that plane. Then if we have another line and notice I put dashed lines here, which shows that this line actually goes through the plane and comes out the other side. And we're going to say this has a point D, and then also point P is on that line as well. Okay? So also put a point on this plane V. And we're going to call this line M and this line N. Okay. So, given this figure here, what would be another name for line PQ, or excuse me, PD? So we have line PD. What would be another name that would be the same as that? Well, remember, for a line, we can just reverse the letters as long as they're on that line, and those would be the same line. Also, what would be another name for plane R? Well, remember, we can use points. So as long as the points are on that plane, we can use those in any particular order. Excuse me. So plane S, P, excuse me, SPT would be another way we could name that. Or we could also name it plane VPS. Any of these points that are on that plane, we could name it that way. Alright, some more definitions. A line segment. Okay, a line segment, or you could just call it a segment with the letters, is just part of a line. Okay, so let's say we had a line that had A, B is points, so this would be line AB. A line segment could be just this portion from A to B. So we could call that segment AB, or we could just name the two letters and put a line segment across the top of it. Notice I didn't put arrows on the end because that would mean the whole line. I wanted to only go from A to B, so I just put a line segment over the top. You could also reverse that. Call it segment BA. Array. Array consists of an endpoint. You have to have a starting point, and then it's all the points in a particular direction from that endpoint. Okay, so if we use this same line, line AB, array, we would have to have a starting point, so we could start like on A, and then go this direction through B. So this would be array AB. Always want to list the starting point first, or we could put AB with the array symbol across the top, which has a starting point, and then it goes on one direction forever. And the first letter is always going to be your starting point. Opposite rays are two rays that have the same starting point but go in opposite directions. So if I added a point C up here, opposite rays then could be ray AC and ray AB. They both have the same starting point at A. AC goes to the left, AB goes to the right. When you put opposite rays together, you end up with a line. So opposite rays are the same as a line. So if I have these two lines that intersect each other, they intersect at point J. We want to give another name for segment GH. So we have line segment GH. What would be another name for that? Well, GH is this segment between G and H, so we could reverse those and say that that is HG. What about rays that have an endpoint of J? Well, we could have ray JF. We could have ray JE, which would end up being opposite rays. Or we could have ray JH or ray JG, which are also opposite rays. So there are 4 different types of rays originating from point J. Okay. Intersections. Intersections are just locations where either two lines or two planes intersect each other. We had an example up here of an intersection of two lines, and it's just that point where those two lines intersect, and you could name it or not, but in this case these two lines intersect at point A. to have two rays intersect, these two rays intersect right here. So a ray, or excuse me, these two planes intersect right here. Planes, remember, go on forever in all directions. So you got to think of these pieces as continuing forever. So if that's the case, then the intersection of those two planes will always be a line. Okay, the last thing is sketching some of these on your paper. See if I can do this. Need to use your template. So let's say we want to sketch a plane and a line inside that plane. Well, a plane is just the easiest way to show a plane is just to use a parallelogram. And then once you have that, you just need to place a line inside that parallelogram, showing it to go through. So that would be a line that intersects. We could call the plane M and the line L. So this line L intersects, or not intersects, but is on plane M. They're both taking up the same space. Okay. So that's a plane, a line within a plane, a line outside of a plane. We're going to make our plane again. Call that plane M. And we just have to show that our line does not go through that plane. So we just stick it up here away from it. So the line L is not part of plane M. And the last one, where we want to intersect plane M with a line at one point, we're going to run a line through this plane. Whatever part that you can't see, you want to use a dashed line. So I'm going to start outside the plane with a solid line, and this is like going through the back of it. As soon as we get to the plane, we're going to start using dashed lines until we get to the point where it's going to come through the plane, and then we're going to go back to a solid line. So this shows that this line L goes through plane M only at this point here. It's like coming through the back of it. So you have to use dashed lines when you know it's part of something that you cannot see. Okay, the last sketch is if we have two planes that intersect each other. The easiest way to do this is I'm going to draw a plane that's kind of at an angle. Then we're going to use a rectangle, and if the rectangle's not big enough, we may have to use it twice here. But notice these marks on the sides that are halfway. If we make those about halfway down our plane here, and try to get them as much inside as you can. So this part's going to be on the outside of the plane that we can see, I'm going to raise it a little higher here. So that's the part we can see, and it's going to intersect across here, and then the part that we can't see will be down below it. So down below it we're going to use dashed lines until we get beyond where the plane is. And it's a little hard to tell, but this is where the two planes intersect. And then we have this part goes down below, so it's kind of going through there. The book has a much better picture, but you kind of get the idea, I think. All right, and that ends this lesson.